I've never seen a number like a ghost. I never had to multiply by infinity, and I'm not sure how to compare 1 0 to another 0, but every song's like differential and infinitesimal, Newton's method, theorems, fundamental calculus. It's not as difficult as it seems, with epsilon and delta limits, L'Hopital and Leibniz, Hook and Riemann, infinites with sizes, if you please. Just throw it back to Archimedes, and you know the difference. Infinite and infinity, infinitesimals are small, as if you had nothing at all, but they're bigger than 0. Like infinite quantity. A differential odyssey. Done. Yes. 40 more integrals? Are you kidding me? I just want to go to sleep. Stupid calculus, stupid Isaac Newton, stupid abstract math. Seriously. When am I ever going to use this? Why didn't I take statistics, or probability, or finance, or German, or something useful in the real world? Darn you, Gottfried Leibniz. Darn you, Riemann. Darn you, Robert Hooke. L'Hopital, you're cool. But most of all, darn you, Isaac Newton.
Who are you? I am Isaac Newton.
What are you doing here? I must be dreaming.
No, I'm dreaming. I'm dreaming. I'm dreaming. Look at your clothes. Look at your hair. What's wrong with my hair? Stop copying me. No, you stop copying me. Stop it. Stop it. Stop it.
Okay.
On the count of 3, say the first thing to pop in your head. 1, 2, 3. Demotion corpus in gyro.
Oh, that's better.
I'll say, this is a strange dream, eh, little Isaac?
Hey, what makes you think I'm in your dream?
Because I just had my reoccurring dream. And like all reoccurring dreams, I'm fairly certain one was about to reoccur.
What was your dream?
Falling. I was standing on the lip of a well when I received a push. Naturally, I suspected Robert Hooke. As I fell for 100 feet, I felt very odd. Because in my dream, as I fell, my speed never changed. You don't look very shocked. Let me be clearer. Instead of speeding up as we used to do in falling, I started faster than expected and just stayed that speed. Then I woke up, went to the kitchen, and ate a pastry, fruit and cake. And while I waited for my dream to reoccur, I conducted rigorous physical trials on little Isaac here.
Yeah, about little Isaac.
When I drop him from a height of 100 feet, he always takes 2.5 seconds to land.
Okay.
And on that journey has an average speed of 40 feet per second. But he does not start at 40 feet per second, nor does he land at 40 feet per second. My dream is not right.
Well, okay.
He must speed up. Because when I start him, he's not going very fast at all.
Yes.
It's very frightening. It means at every point along his journey, he's traveling at a different speed. But how can I measure speed at just one point? The only way I can measure speed is to divide distance by time feet per second. But in one instant, there is no distance, there is no time, there is no value at this point. Oh, thank you. I needed that.
You are nothing at all like I expected.
Ooh, who were you expecting?
I don't know. I guess I thought the inventor of calculus would be someone a little more grounded.
I was just talking about falling. How more grounded can one get? Ground.
I wonder if I'm going to dream about any of the other mathematics mathematicians from my textbooks, like Guillaume Francois Antoine Marquis de L'Hôpital, or Gottfried Leibniz, or Archimedes, or Robert Hooke.
Who?
Robert Hooke?
Who?
Robert Hooke.
Who?
Robert Hooke?
Never heard of him.
You just mentioned him a couple minutes ago. Well, you totally know who I'm talking about.
Nope.
English scientist. Curly red, wig. Squinty eyes. Small mouth. Robert Hooke.
Robert Hooke!
Hello, Isaac. It's me, Bob.
I've been meaning to remind you, Mr. Hooke, about the marvelous properties of prisms and how they distinctly break white light into different particles.
Oh, I think you'll find, Sir Newton, that the light is not being broken, it is merely being changed.
I think you'll find, Mr. Hooke, that had you done the experiment and had you done it correctly, you would have reached the same conclusions that I had.
Oh, I did the experiment correctly, and it led me to conclude that your ideas are stupid.
Light breaks up.
Light doesn't break.
Light is a particle.
Light is a wave.
Particle.
Wave.
Particle.
Wave.
Particle.
Heavenly spheres.
Aha! Science.
Oh, how about a little research on elasticity?
Friction.
How's this for standing on the shoulders of giants?
God, you sprinkled psychopath.
Fancy a little fluid dynamics?
No. Microscopic maniac!
Why are you-
I'm not touching you.
Stop it.
I'm not touching you.
Stop it.
The finger draws closer than any measure could exist, but I'm still not touching you.
Stop it.
The distance decreases from 1/millionth of a hair's width to 1/billionth of a hair's width, but never will the finger touch your vile flesh.
Stop it. There's no point to this tomfoolery. Your treachery knows no limits.
It's gonna have his way tonight. His fingers on their way from left and right. You say there is no point there, so what? A limit can exist there even if there is not a point. And if I may be on point, I'm going to demonstrate a point in your face. As my finger draws me in a rude invasion of your personal space. It's getting closer, but never touching you because you are too gross. That's right!
Old Hook feels like he's gonna croak tonight. I'm gonna crack you like your broken light. As epsilon and delta grow small, their arbitrary values near nothing at all.
But fight!
There is no option of flight. You aren't touching me, so I won't be swayed. The distance drops to a hair, but just remember that you've never been paid.
Is there a limit?
Is there a limit?
A limit how low you will sink in a fight! Fight! I'm tracing back along the flow inside. Emergent fluxing on the zones to slide.
I'm beating at the middle. Value, an answer to the riddle, is coming up through.
The right, from left and from the right. And if they need a limit, is there? It's tight,
Alright.
from left concurs with right. If they need, then our limit is there. The space between them is so tiny,
One might say microscopic,
but something smaller yet. And when
they meet,
a value will exist. Limits might be raised. Instead of finding little Isaac's speed at a particular point in time,
we find little Isaac's position at a particular point in time.
then we find his position an arbitrary amount of time later.
Then we use the notion of the limit to slide the amount of time that passed to become infinitesimally small.
I shall call this a fluxion.
Yeah, we'll work on that.
Then we find the distance between his first position here and his second position here.
This distance is also infinitesimally small, but now, when we divide the infinitesimally small distance
by the infinitesimally small time, we get a normal, everyday, finite number like 37 feet per second.
This is little Isaac's instantaneous rate of change.
His speed at just 1 point.
His slope.
His derivative. I can find little Isaac's instantaneous rate of change at any point along his journey. I shall call this y dot.
Y dot?
Why not?
Hey, where are you going?
To play with my metals.
Aren't you going to tell anybody about your discovery?
Why?
Because it's important.
Why?
It's a major principle of physics.
So
what's more important than that?
the Philosopher's Stone.
What?
It can turn anything into gold.
Are you being serious right now?
Yes. Toodles.
Hey, if you don't publish, somebody else is going to publish first. They're going to come up with better names for your functions. You're going to have to share the credit. Okay, we'll do this your way. Hello, Isaac. It's me, Gottfried Leibniz.
Not German enough.
Hallo, Milton, it is I, Gottfried Leibniz.
Leibniz?
Guess what I just published?
You didn't.
I did. Now I know we have this little disagreement as far as who came up with exactly what and who came up with it exactly when, but at least there's one thing we both know for certain, and that is who published first, right?
Oh.
But we're not so different, you and I.
Oh.
It's just that one of us is a procrastinator, and the other is a German. But I looked at your work, and I think we agree. But the words that you use are confusing to me. You say the word fluxion, and it is essential that I mean the same when I say differential. Now you say y dot when you mean the change of distance to time, which I think is strange. I think it is clearer if you were to say dy dx, differentials at play. Now consider a curve, f of x as it's called, and 2 points are a distance apart. The distance is h and it drops till there ain't any base that will tell them apart. The height at point x is simple to find, f of x as its friends like to call it. The height at the other point, x plus h. F of x plus h, even though it sounds strange. Now subtract them, divide, and take limit. F of x plus h minus f of x all over h as h drops to 0 is the formula to find the derivative to otherwise state instantaneous rate.
F of x plus h minus f of x all over h as h drops to 0 is the formula to find the derivative to find the slope at 1 point. Infinitesimals dy over dx. Why he wrote it I can't say.
I just liked it better that way.
So f of x plus h minus f of x all over h as h drops to 0 is the formula to find the derivative.
This
I will have to learn to call Leibniz found the limit of the slow.
Yeah. Daddy's English monkey.
Oh, flexion!
Differential. Differential.
Infinitesimals
Divide over dx. What I wrote it out that way.
Leibniz liked it better that way, so
f of x plus h minus f of x all over h is h drops to 0 is the formula to find the derivative.
This sounds a little too cold. Leibniz found the limit of the slope.
Hey! Hey!
Game?
Hey!
Are you done? Hey! That's Leibniz, everyone. Clap.
So, are you going to publish now?
I guess so.
I guess so.
Stop copying me.
Stop copying me.
I mean it.
I mean it. Stop.
Oh, Germans. I'm German and I like to publish things. I'm so cool. I say the word schnapp.
I just made that up.
I'll show them how a real scientist publishes. Yes. The derivatives of polynomial functions by Sir Isaac Newton. The derivative of x to the power of 5 is 5x to the power of 4. X to the power of 4 becomes, stop it, 4x to the power of 3, x to the power of 3, f of x plus h minus boring. There's got to be a better way. Every time it's f of x plus h minus waste of time. To heck with publishing.
Can I take a look? Okay. Every x to the power of 4 becomes an x to the power of 3. Every x to the power of 3 becomes an x to the power of 2. Every x to the power of 2 becomes an x to the power of 1. Yeah, but then there are these numbers in front that keep changing. I think every different power has to have its own unique rule.
Well, I'm stumped.
What, so you're just gonna give up? This is a group project now, buddy.
Everybody knows a group project is an excuse to slack off and eat fruit and cake while someone who cares does all the work.
Isaac! Come on, man! I'll have you know I have been up all night studying your stupid rules. Thanks a lot. What a nightmare.
Have you ever had that nightmare where you're standing on stage in front of an entire school?
Oh, I have that one all the time. It's the worst because you're stuck and they're stuck and nobody can get lunch and
Right.
Oh, no, Isaac, no, come on, no, we can use this. No, this is good, We can use this to solve our problem because in my dream, there's an energy that takes over the crowd and they can't stop cheering.
Well, cheer, come on!
And a dramatic wind swirls through the auditorium for theatrical effect while the audience can't stop losing their minds!
This dream of yours, wow, it's as exciting as my experiments with Mercury.
I'm gonna harness the power of my dreams and solve this problem of powers with a power ballad.
Uh-oh.
You're gonna reveal to the half power. X to the -1, A1 over X tower. When you need the change, X to the B. How to change it from X to the B. I'm starting to like you.
And I you. We are best friends.
Well, I really
We
said
are
that.
inseparable.
I did not say
We
that.
shall have a jeweler make us a little metal heart with the letters BFF engraved on it. For best friends for eternity. Then we shall break the heart in half and each carry a piece to remind each other of our undying friendship.
I hate to break it to you, but you are not my best friend.
Oh, I will be. It is mathematically proven.
Really?
Yes. Did you like me when we first met?
No. Well, no offense.
Oh, none taken. Did you like me better after I stopped copying you?
Yeah, I guess so.
And what about after our first song?
Okay, that was pretty fun.
And when I had to poke my eyes out? And now I'm liking you.
Well, yeah, but that doesn't mean we're best friends.
But if we continue this mathematical trend, we shall soon be the greatest friends the world has ever known.
But my rate of liking you is decreasing.
I don't follow.
Can I borrow little Isaac for a second?
Oh, no.
So I throw him up, and he's going up, but every instant, he's going up less and less until at his peak, he stops.
Ada, this is critical.
Exactly. We reach the critical point where going up less and less is no longer going up, but going down. And likewise, I've reached the critical point in our friendship where I'm gonna like you about as much as I can.
Well, I don't want to peak too soon.
But on the plus side, my frustration with you is beginning to trough.
Oh, perhaps your frustration with me will trough at the same time your liking for me peaks, making a kind of half peak, half trough monstrosity.
That joke was just sad.
Yes, a saddle.
That's not even what I said.
A point of infliction.
I swear, sometimes your words are gaga nonsense.
I'm gonna let you finish, but if you follow the graph of our friendship...
Sit down, Kanye. Just take the first derivative and stay with me. Positive or negative means slope is up or down. And zero tells you where a critical point can be found. Oh, zero, zero, a critical point, a critical point. Oh, zero, zero, a critical point, a critical point. Do it once, do it twice, and you will see where my glass contains. Just a smile, let's frown, and then you'll know where my glass contains.
Concave up or concave down, down, down.
Second derivative, oh inflection point. Second derivative, oh inflection point.
I can tell you if you're addled, it's a saddle, curly trouble, zero, double, critical point intersection with my point inflection. Just like a change in So, little Isaac, I still care about you.
Do you two need a minute?
But the word best implies that you like that friend above all the others.
I'm gonna give you two a minute.
Apologies, little Isaac. But you and I, our friendship has already reached a global maximum. While Ada and I, our friendship is only approaching a local maximum, followed by a local minimum, then up and up and up to BFFs. We've reached global maximum? Yes, just like the one you reached when I tossed you up. Profit! All right. Oh, look. The equation for your height to respect time is here. The derivative shows me how fast you're moving at every instant, so I find the instant where you have stopped completely, and that appears to be your maximum. The instant before, you're still going up. The instant after, going down. Absolute maximum at your peak. QED. Schnopp. Do you say schnopp now because Leibniz says schnopp? I was saying schnopp long before Leibniz was saying schnopp.
Stop copying me. Schnopp.
Germans! What about my trough? You don't have a trough? You're not a horse? What about my minimum point? I want a trough! Your minimum point is when you hit the floor. I mean, when I catch you, as long as it's lower than when I let you go. What about saddles? No saddle either. You are not a horse! I think I can explain this better, but I'll need to obtain some assistance. Ada! Ada? Ada!
What's up?
We have an idea for a group project.
Okay, how many people do the two of you need?
3 stoic audience volunteers should do it.
Can I get 3 stoic audience volunteers? Starting with this individual right here. This guy right here. I need 2 more stoic audience volunteers. There's one. And you. Very nice. You'll line up right here in the center. What would you need? Sana and Diana. And Daniel, thank you very much.
Now, we are going to sing a little song. You will be saddle, you will be peak, and you will be trough. Now, when I say the word saddle, you are going to bring that sign up and bring it back down really fast. Okay. Wow, you knew exactly what I was asking for. Saddle. Nice. Let's try peak. Good. Trough. Hey, they got it. Will you sing along, Ada?
I'll try, but I'm a little hoarse. High five. Oh, Isaac, right there, right there. He left me hanging.
He's waiting for the main event. For maxima and minima, just take derivativima. Happiness, now you assess the 0, 0, 0, 0. Don't forget you must inspect the endpoints as they are suspect. Find the values of our functions, look for highs and lows.
Local maxima.
Are on an interval.
Local minima.
Are on an interval.
Global maxima.
Are on an interval.
Global minima.
Are on an interval. Turbo, turbo, turbo. Saddle, peak and trough and saddle, peak and trough and saddle, peak and trough and peak and trough and peak and trough and saddle, peak and trough and saddle, peak and trough and saddle, saddle, peak and trough and peak and trough. Maxima and minima are also called the extrema. Sometimes they can be absolute, as long as there's no greater or lesser. Relative implies a region that the extremum are in. Don't confuse a saddle point. Don't confuse a saddle point. Don't confuse a saddle point with an extra Do we need more extra notes?
Just tell me when you're done.
Oh, I was just vamping until you were ready.
Saddle, peak and trough and saddle, peak and trough and saddle, peak and trough and peak and trough and peak and trough and saddle, peak and trough and saddle, peak and trough and saddle, saddle, peak and trough and trough.
Yes! Wonderful. Now we are just going to freestyle dance. hands. Just shake those signs, everyone. Da, da, da.
Wait. No. Hold still. I want to see this.
Okay.
Yes. I do see this everywhere in the real world. Bridges, buildings, roller coasters.
Well, why did you stop? Keep shaking your signs, everyone.
No, hold still. I want everybody to look at this. Yes. Even the abstract things are starting to make more sense now. Like orbital velocities and rates of growth and even elements of designing video games. They're all based on this simple thing right here.
Shake your extra mind.
Isaac! We're done. Thank you so much. You can wait here for just a moment. Thank you so much. Let's hear a round of applause for our stoic audience volunteers. And so thank you for your time.
These things?
Yes. Thank you. It's the all-star cast recording of the soundtrack of Calculus the Musical. Another round of applause as they find their seats. Thank you so much.
Angel, we were having fun. Whoa, frustration.
Isaac, I am really trying to help us both out here. I am trying to move us both forward with this whole calculus thing, but you just want to play around all the time with your dance parties and your snacks and your creepy action figures. Seriously, what is my subconscious trying to do to me? Why couldn't I have had a dream about somebody awesome, like Marie Curie? Or, I don't know, somebody not annoying and actually dreamy, like L'Hôpital? Yeah, that's a mathematician I'd like to see dancing around my head at night, but you, Cookie Man, are my anti-derivative.
What did you call me?
My anti-derivative, pastry head.
What did you call me?
My anti-derivative, biscuit eater.
Oh, antiderivative. That sounds integral.
Actually, yes. If a derivative is taking a step forward, the antiderivative is taking a step back.
So you're saying it's like we take 2 steps forward and 2 steps back.
Pretty much.
2 steps forward and 2 steps back. Antiderivatives reverse a process back. So add C. This addition makes the puzzle come back. Antiderivatives reverse a process back.
That possibly a Paula Abdul song? How do you know who Paula Abdul is? I don't think they even know who Paula Abdul is.
Antiderivatives, they are too legitimate, too quit it. Too legitimate, too quit it.
Thanks, Einstein. E equals MC hammer squared. Dumb.
No, Ada, antiderivatives, they have my mind all fired up. Like a red, hot, chili pepper.
Dad rock.
Area under that is equal to the antiderivative of f of x dx. It is fundamental geometry. The integral from A to B, antiderivative, take the value at B sub, track the value at A, integral from A to B, antiderivative, take the value at B sub, track the value at A.
amazing.
Is it?
It's the fundamental theorem of calculus.
It's the fundamental theorem of calculus! It's the fundamental theorem of calculus!
I think you have to tell everyone how it works.
Well, easy. It works because it is mathematically true.
Yes, but why is it mathematically true?
Because math.
But why?
Because math.
But how do we know that? Triangles!
May I wear the costume this time?
Go for it.
Yes!
It all started 2,000 years before Isaac Newton in ancient Greece.
Hi, friends. Archimedes here. I'm just taking a break from the bathhouse to let you know that I've developed a method that has the power to find the area of any shape. No, I hear what they're saying. They're saying, but Archimedes, what if this shape has a curve? How am I supposed to find the area under a curve?
We don't know.
Well, friends, the secret is in finding the area of a triangle. We simply multiply base times height, take half the product. A equals 1/2 base times height. There we go. So what you're going to do is you're going to draw yourself a point on that curve, and then draw yourself a triangle and write down its area. But I'm not stopping there. I'm going to throw in another triangle using the first triangle as its base. And then another triangle, and 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 another triangle. Can you show me another triangle? How about another triangle? What about another triangle? Yes, and another triangle, and another triangle, and another triangle, and another triangle, and another
Time to clean this method up a little bit. Fast forward to Germany, 200 years after Isaac Newton. Enter G.F. Bernard Riemann, the original home slice. As it's my turn to wear that costume.
Oh, I like the toga. Toga, toga.
Right. Before you stepped out of your bathtub time machine, you invented music, right, Archimedes?
That was Pythagoras. That would be like me confusing you with David Hasselhoff.
That you're obviously familiar with this work, so make this a beat, yeah?
Ugh, Germans.
GFB Riemann. No gimmicks. To find the whole area under the curve, under the curve, under the curve.
A, B, A, B.
To find the whole area under the curve, under the curve, under the curve.
A, B, A, B.
Interval. A to B. F of X. Stay with me. F of X, 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 F of X. I'm using rectangles to find areas, so I use slices. One to angle. If you want slices, this is what I'll tell ya. Each of the width is B minus A over N, cause width is changing on the X. It's delta X and height. F of X, the back from the middle of the right or left, cause you're evaluating from the eye of the slice that you are calculating. The area is from multiplication of the base to the height. It needs some adulation. You know you got sigma notation when your slices add up to a big summation, so the big CE won't disagree. Let me decree Archimedes. He had the same idea in ancient Greece, but it feels exhausting without Riemann. Remember, kids, some of the bits more cutting in width, converting in skits to get on it. It's all working out. You don't show it. I just set up my summation time to sum it.
Yeah, this looks like a job for Riemann.
Add it up from A to B, and the more slices that you see can increase your accuracy.
Yeah, this looks like a job for Riemann.
Add it up from A to B, and the more slices that you see can increase your accuracy. Little slices Macarian nicest. The smallest of sizes will be the precisest. Infinitesimal bits will entice us till someone comes along with a vision and yells. Visionary, vision of area. To start the transformation, solution is changing with limits. And it's getting greater, so vast that it's a fact that then without those little slices I'll last to count them. Such a catastrophe, because there could be enough time to count to infinity. But step back. There's no with the major truly sensations will let our different delta, a differential trendsetter. They're missing no notation, slimmer is better, it's the best thing. Yes, thing suggesting, divesting X of the sublime, stressing.
Anti-derivative.
When I mentioned integral, fx, dx, who made sense and since from A to B, and Newton, not him.
No, not me. No, this looks like a Joparima.
Add it up from A to B, and the more slices that you see can increase your accuracy.
No, this looks like a Joparima.
Add it up from A to B, and the more slices that you see can increase your accuracy.
Yeah, this looks like a Joparima.
Integral from A to B, and slice to infinity for your perfect accuracy.
Of math. You go, girl.
Isaac, this is awesome. I am finally starting to see that the world has an order to it. I mean, I used to think calculus didn't have anything to do with anything, but think of all the relationships.
Relationships?
I can see so many natural, physical relationships.
The physical relationship?
The way the bodies interact and react to the stresses of the world around them.
Friend, I should mention I have a vow of celibacy.
It's so awesome to understand that the integral of force, the derivative of forces work, and the integral, the force, and any object, no matter how massive or how fast it's traveling, always falls to Earth with the same acceleration.
Oh, yes, those relationships.
Position is the place you are at any given time you see.
I am here.
The instantaneous rate of change of that is the velocity.
Moving over here.
Which is direction and the speed, two parts of information.
1, 2.
The instantaneous rate of change is called acceleration.
Vroom, vroom.
The total distance traveled is by no means an atrocity. The integral of absolute value of the velocity. Another point of interest, no, the integral of force is work. Acceleration's rate of change is surge or lurch or jolt or jerk.
Acceleration's rate of change is surge or lurch or jolt or jerk. Acceleration's rate of change is surge or lurch or jolt or jerk. Acceleration's rate of change is surge or lurch or jolt or jerk.
Displacement is how far you are from your initial starting spot. Remembering the average value of a function is a lot.
That's a lot.
1 over b minus a times the value of the integral from a to b of f dx upon an interval.
1 over b minus a times the value of the integral from a to b of f of x dx upon an interval.
Secret handshake.
Secret handshake. Ada, your brain is as luminous as quicksilver. I shall go publish.
Yes!
And the world shall know that I, Isaac Newton, invented calculus and physics when no one else could.
You're kidding though, right?
No.
I mean, you realize there were tons of other people who allowed you to succeed.
Well, I never met any of them.
Are you being serious? We just saw Gottfried Leibniz.
Germans!
And Robert Hooke.
Robert Hooke!
And Archimedes.
Toga.
And
Hat drop.
and tons of others who didn't even show up in this dream. I mean, if we had all night, we would see Bernoulli, Barrow, Euler, Gauss, Simpson, Stokes, Cauchy, Ramanujan, Descartes,
Euclid?
Fermat, Zeno, Pascal, Jean-Laurent d'Alembert, and you know, there's another French go-getter that I'm actually really bummed I didn't get to meet.
Define go-getter.
Well, he wrote and published the first calculus textbook. He's this French dude who got credit for developing this super awesome rule that makes it so much easier to evaluate the limit. And it's It's my favorite rule, and I use it all the time, and I think it's super useful and super awesome, even though somebody else probably came up with it first. Oh well.
Ada? There's someone that I'd like you to meet.
Lopita! Lopita!
Every now and then I get a zero for the numerator as a denominator.
Lopita!
Every now and then I get a limit that's confusing as a kind of indeterminate form.
Lopita!
Every now and then I get a little bit terrified, because then I think of all my advice.
Lopita!
Back to the world of wake.
I guess so. Hey, you have fun, you know, doing your thing in 17th century England.
You have fun. Going back to the future. Ada, did you find what you were looking for?
You mean besides a kooky British guy who eventually gets mercury poisoning and dies alone?
No. I meant, did you find this? It says calculus.
I can read. Yeah, I think I did. Thank you, BFF.
Once upon a time I had trouble with math, but now they all think I'm smart.